Hi everyone. In this video, we are going to look at how to simplify fractions. We have three learning objectives. First, we look at how to simplify a fraction to the lowest terms. And also, we simplify improper fractions, also mixed numbers. And finally, we are going to simplify rational expressions. A rational expression is just another fraction, except that you have polynomials in the numerator or in the denominator or in both of them. Okay, let's look at it one by one. First of all, we want to know what is called lowest terms. And when a fraction is in its lowest terms, you cannot simplify it further. For example, so we have this 8/12, and we can divide both sides by 4, and the result is 2/3. And 2/3 is equivalent to 8/12. But 2/3, if you look at these two numbers, there's no common factors anymore other than 1. So you cannot reduce it further by dividing by same number on both sides. So this is called the lowest term. You cannot simplify it further because there's no other common factor or factors other than 1. Now let's look at our first example. Now we want to simplify 18/24 to its lowest terms. And as long as we divide both sides by the same factor, same number, we will be able to reduce it. And you don't have to divide by the greatest common factor, but if you can identify greatest common factor, in this case, which is 6, it's good. But you don't have to. As long as you divide both sides by the same number, you will reach the lowest terms in the end. Okay. First, if I see the greatest common factor, which is 6, I divide both sides by 6. It's going to be 3, it's going to be 4. So 3/4 is our final answer. But alternatively, if you don't see the greatest common factor 6, you can still reduce it by dividing both sides by 2, because both numerator and the denominator are even numbers. They can be divided by 2. So if I divide by 2 on both sides, I get 9/12, right? But take a look at it, because we want to have lowest term, and both numbers can be divided by 3. So we continue divide both numbers by 3. So there's going to be 3, there's going to be 4. You see, eventually we get the same answer as long as you divide both sides by the same number until there's no common factors in between. Okay, let's move on to the next page. And your first exercise problems, 2 of those. Answers to these exercise problems are in the comment area below the video. Now move on to our second example. This one, we want to simplify -72/90 to the lowest terms. And first, both sides can be divided by 2. And if you think about the multiplication table, both sides can be divided by 9 also. So either way is okay. We are going to get our answer. The answer will be the same. So if I divide by 9 on both sides, just make sure you always divide by the same number on both sides. Look at this, 9/9 is 1. When you divide by 1, it won't change the value, right? That's why we have to divide both sides by the same number. So this is going to be 8, and this is going to be 10. So we can still divide both sides by 2. Both are even numbers, this is 4/5. So this is the final answer. This is the final answer. And the second set of exercise questions here. Move on to our third example. According to a survey of 182 people, 112 of those surveyed responded that they had seen a particular movie. Write in lowest terms the fraction of people in the survey who had not seen the movie. Interpret the results. We are interested in those people who had not seen the movie. So totally 182 people. Among those, 112 had seen the movie. So we subtract 112, which is 70. So that means 70 people had not seen the movie. And we are looking for the fraction that represents this 70 people, 70 out of the whole thing. Fraction represents something we are interested in out of the whole thing. So we would use 70 divided by 182. This is the fraction that represents those who had not seen the movie, but we need to simplify it. At least I can see both sides can be divided by 2 because they are even numbers. So divided by 2, we got 35. 18 divided by 2 is 9. 2 divided by 2 is 1. 91. Now, can we simplify it further? Now they have to divisible by the same factor, right? So in this case, we always try to look at the smaller number. 35 can be divided by either 5 or 7. Apparently, 91 cannot be divided by 5 because only those numbers that end with either 5 or 0 can be divided by 5. So this one, 5 is out of the question. How about 7? Let's try 91 divided by 7. This is going to be 1, 7, remainder is 2, 21. Yeah, it can be divided by 7 evenly. So both sides divided by 7, you get 5 up here. We got 13 on the bottom. So if we solve it, we finish it. So the interpretation is that 5 out of 13 or 5/13 of total people surveyed had not seen the movie. Now you have 2 application exercise problems, and write the fraction and then reduce them to the lowest terms. So you have 2 of this. This is the second one. Yeah. Okay. Now let's look at our next objective. We want to simplify rational expressions. So here are some of those rational expressions. You see, they have polynomials. In general, monomial, binomial, they belong to polynomial. Right? That's why we generally say you have polynomials on either side or both sides, and then we call it a rational expression. So this is the formal definition. A fraction in which the numerator and denominator are polynomials. So these are called rational expressions. Now let's go to the next page to see how to simplify them. We start with the simplest one. We have monomial on one side, monomial on the other side. And this is very easy to do actually. First, we simplify between numbers. Both sides can be divided by 4. So number-wise, we have 1 left on the top, 2 on the bottom. And if there's something else, you don't need to write 1. See, because 1 times anything won't change anything. So here we have x cubed, which really means x times x times x. And on the bottom, we have another x. So it's like we have a common factor of x. We can cancel common factors. So like x divided by x is 1. It's canceled. You only got 2x left on the top. So eventually we get 1 times x squared over 2. So that just x squared over 2. And that is our final answer. Actually, we can do this directly from here to here. you notice that we cancel 4, we have 2 left on the bottom. And then we compare x to see how many on each side. The one with the fewer x will get canceled. You have 1 x on the bottom, 3 on the top, 1 get canceled, you have 2 left on the top, right? So we can write this directly in one step, actually. Now, here is your next set of exercise questions. And now let's look at our next example. We have another monomial divided by a monomial. And there's no fundamental difference compared to the previous example. We just have a bigger numbers, more variables. Otherwise, the way we do it is identical. So between 16 and 28, both can be divided by 4. So if I divide it by 4, I get 4 left on the top. I get 7 left on the bottom. Now let's write our variable part. We have 5p on the bottom, which means p, right? They multiply together. We have 3 on the top, 3 get canceled. We have 2 left on the bottom for p. How about for r? R entirely canceled because anything divided by itself is 1. Entirely canceled. We just have s left on the top. So this is our final answer. It's very straightforward. And next page. This is the exercise number 5. And this is the last one. This is the last one for this video. There's no more example. Okay, see you in the next video.